All right, let me first of all apologize here if I end up having to sneeze or cough or sniffle or do a bunch of things. Allergies got the best of me this afternoon, and some things just aren't going well. But without further ado, this actually shouldn't take too long compared to that of the other 8 problems we did. This might seem like a lot, but it's really not. We have a chapter review solutions guide here, and although I'll be going over through the problems one by one, make sure that you try them on your own as well. You don't just learn by watching, you do learn by doing and by practicing. So you might be like this dog right here, but eventually you will know what you're doing. So let's go with the first 7 problems, and they're just matching. They're just making sure that you know the definitions. You won't have problems like this on the test, but you are expected to kind of know what they mean. So I'll just go and match them up and start to explain them here. A blank is a change in position, shape, or size of a figure. Well, it's what the chapter is all about. Transformations is a change in position, shape, or size of figure. Now remember, the only real ones are change in position and like orientation, except for the size, and that's with dilations. So we'll talk about those ones. A blank is a transformation in which, wish I could spell which, in which the pre-image and its image are congruent. So we learned that word as isometry. If something's isometric, then the images are congruent, the pre-image and image. A blank is an isometry in which a figure and its image have opposite orientations. We talked about those as reflections. If it has opposite isometry, opposite orientation, etc., they're different. They're not the same. They don't match up. They're a flipped image. Number 4, a blank is an isometry in which all points of a figure move the same distance in the same direction. Well, that one's a translation. Remember, when we move a translation, everything still stays the same. We're just changing its place in space. Or I guess on a plane. Okay, number 5. A blank's a translation followed by a reflection in a line parallel to the translation vector. We'll talk about translation vector later, but translation followed by a reflection, that's the one transformation that's like different because it has 2 things. That's a glide reflection. That's B. Number 6, a blank is a repeating pattern of figures that completely covers a plane without gaps or overlaps. We learned that was a tessellation. Nice fun word there. So tessellation has that repeating pattern thing. Number 7, a blank's a transformation that proportionally reduces or enlarges a figure. That would end up as dilations. Process of elimination, we could figure that out as well. A. So there are our 7, and hopefully you know those definitions just for the future here. All right, so our first problem, given points A at 6, 3. Now, these things I already drew out for you, but you're going to have to draw them on your own. Given points A at 6, 3, B at negative 2, 1, and C at 5, 0, draw a triangle ABC and its reflection image in each line. So here's the line that we're going to reflect across x equals 4. So here's x equals 4. It's a vertical line where x always equals 4 no matter what y is. So we'll go ahead and reflect it across that. So let's choose all our points. Let's go for A, and let's reflect it across here. 1, 2. 1, 2 units over. We get A prime. C is 1 unit away. So here's C prime, 1 unit away on the other side. And B is 1, 2, 3, 4, 5, 6. So we'll go 1, 2, 3, 4, 5, 6 units over. It's always best just to treat each individual point as its own thing, and then you reflect it across. So I'll go ahead and connect the dots here. Whoops. Let's make it green, and let's, it's a different green. So here's my new triangle right there. That should look like a reflection. Okay, use matrices to find the image of each triangle for the given translation. So you have triangle ABC with vertices A at 5, 9, B at 6, 3, C at 1, 2, and here's our translation vector. You might see translations look like this. This is called a translation vector, or you might see a rule for translations. Like for every x and y, we'll go x plus 2, y plus 3. So like that. These are the same thing. They're just written differently. So for this thing, I have to translate it 2 units over and 3 units up. Let's go and use matrices for it. A, B, and C should have matrices 5, 9. Remember, x's, then y's. 6, 3, and 1, 2. And let's add it to a translation vector, where I add 2 to every x and 3 to every y. In the end, we'll get a new triangle and call it A prime, B prime, C prime. Go ahead and use blue. I feel like I got to sneeze. So you add entry by entry. For instance, this 5 adds with that 2, and I get 7. And it goes in that corner. This 6 adds with this 2, and I get 8. This 1 adds with this 2, and I get 3. And then this 9 with this 3, and I get 12. This 3 with this 3, and I get 6. And then this 2 with this 3, and I get 5. So here should be my final coordinate points for the translated vector. I get A prime at 7, 12, B prime at 8, 6, and C prime at 3, 5. Now the triangle should look the same, so I already created a blue one on top that I'm just going to move over here. I'll take it and go, whoops. I'll take it and I'll go 1, 2 units over, 1, 2, 3 units up. And those final points, that A prime, B prime, C prime, should be in those proper points. A should be at 7, 12. B should be at, or B prime should be at 8, 6. And C prime should be at 3, 5. And there we are. Okay. Number 15 here. Copy each figure in point P. So I already did that here. Draw the image of each figure for the given translation, or for the given rotation about P. Label the vertices of the image. So this one we want to rotate everything 180 degrees. That means that for F, for instance, I want to go like the same distance away from P, 180 degrees on the other side. So F here, this I'm this far away from P, whatever you want to call it, the radius of a circle or whatever. I want to take that and basically, if I clone this, well, infinite cloner, I'll take that, and then I want to rotate it 180 degrees. Like this is about 90, and keep going. 180 would be that straight line around. Now I don't know if this is a perfect 180 degrees or whatever, but this is where F prime would be about. 1 second. So F prime is located on the other side. The other way that we've talked about it was actually with circles. Now you don't have these tools with you unless you have a compass, but say you take a compass and you draw a circle with this radius here F, or with this radius here going out to F. You go 180 degrees around the circle, and F prime's on the other side of that, whatever 180 degrees, about that diameter. So I could go across like that, and boom, F prime should be over there. Right there. So I'll go ahead and put F prime right there. Let's do red. F prime should be about there. And all the other ones do the same. D is on its own circle. In this case, it's probably right next to it in terms of the circle. It goes 180 degrees across, and there's D prime. And then E prime also goes 180 degrees across, like that, sort of. And it goes on its own circle, just a little bit outside of it, same distance away from P. And there's E prime. So I've marked them and labeled them correctly. Now I just connect all the dots, give or take. And the things that should happen, it looks like I didn't do it perfectly. I'm just kind of here and there. Things that should happen, because this is a horizontal line, so should this. Because this is a vertical line, so should this. And these lines should be parallel. So I didn't do it perfectly. I'm just kind of roughing it. But these should be the same distance away from P. About. Okay. Moving on. Find the image of each point for 90-degree counterclockwise rotation about the origin. So at this point, negative 4, 1, let's rotate it 90 degrees counterclockwise, which means we got to go that way, 90 degrees. So kind of the same thing here. We want to take this, figure out how far away we are from the center, because that's what we're rotating about. And then we want to go 90 degrees and figure out where we finish. In this case, it will actually be at this point. And you might ask, well, how do I already know that? If you draw this on a piece of paper, go ahead and rotate your piece of paper 90 degrees that way. So basically, now this is the left side of your X.